Look at this, Paul. This is a real drip irrigation system. Why you've got up at your place is a toy. What you need to do is sell that gated pipe, put in a proper system, save water, help out society. Get with the program, man. And look at this, Paul. You're wasting water. Send it down the drain. People need water in this area. You can't do that. And another thing, Paul, we've been telling you over and over that raising hay takes too much water. You got to crop switch. That's what it's all about, crop switch. Are you dense or ignorant or just don't care? Hi, I'm Paul, and this is The Long Green Line, a program about invention, adaptation, and growing plants. In this series, we're testing out an invention to hook drip tape directly to gated pipe. And in the series, in the process, we're growing a garden that's 2.5 feet wide and 1,000 feet long, a long green line. This is episode 4 of this series. The the episodes build on each other to some extent, so you may wish to watch the first episodes before you watch this one. And today we're going to talk about water. We're going to address those points brought up in the opening clip. This is going to take a minute, so grab a chair and let's talk. Don't worry, I had a chair nearby. So let's start out talking about irrigation efficiency, and let's talk a little bit about what irrigation efficiency is. It's basically a measure of how much of the water that a farmer puts onto the field becomes actually available for the crops to use. A highly efficient irrigation system means that most of the water actually becomes available for the plants to use. So the question at hand is, does highly efficient irrigation make more water available for other uses? And the answer is no. No. What do you mean no? It's a very common belief that if the farmers will put in efficient irrigation, there'll be other water available for other uses. Well, I could explain this by drawing some diagrams or by doing a mathematical example, but I think I'll explain it conceptually. Think of the plants. The plants are physiologically programmed to use a certain amount of water if it's available. And the plants don't care whether that water is delivered by flood irrigation, furrow irrigation, or delivered one drop at a time with drip irrigation. The plants are going to use what the plants are going to use. So I ask you, if the plants are going to use the same amount of water regardless of how we put it on, then is that going to free up any water for more uses if we put it on efficiently? And now you see the answer is no. It's all about how much consumption the plants are doing. And you get my point. If they don't change their consumption, we don't have any change in the amount of water available for other uses. So then the question becomes, well, what is the good of efficiency? Well, it's good for the individual irrigator. It's good for a person like me that if I put in a highly efficient system, then less of my water escapes me. I waste less water and I can use it for my crops. You know, it's ironic. I have neighbors who tell me, Paul, I put in a sprinkler system, switched from gated pipe to sprinkler, and my hay production has increased. Well, good for them. I'm happy for them, but let's think about that. How is it increasing? Well, it's because they are getting water to their plants better, and the plants maybe were limited before, couldn't do all the consumption that they had the potential to, and now the farmer is able to satisfy the plant's full consumption needs, and the plants are consuming more. I mean, there's no free lunch. If you're going to have increased yield, that means you're going to have increased consumption. So isn't it ironic? A lot of the world thinks that the key to Western water problems with not enough water is to ask the farmers to increase their irrigation efficiency, but it's actually quite the opposite. Maybe someday there will be bumper stickers that say, put in a sprinkler, dry up a river. Now, I do want to point out that increased irrigation efficiency does have a side effect that can be quite useful to the other water users in the area, especially downstream, and that's that it helps with water quality. If water runs off my field, sure, it's going to be used by someone else, but the water may be lower quality because of the soil it picked up. I hope not. I love my soil and I don't want to wash it off the farm. But anyway, there might be salt or other agricultural chemicals. So from that standpoint, irrigation efficiency is a good thing. But when it comes to increasing the amount of water available to other people, I think you get my point. It doesn't do it. Okay, so now let's talk about wasting water, like you saw me running water down the drain in that opening segment. Is that water being wasted? No. So why not? Well, to do that, to answer that, I think we'll look at a photo of one of my fields. So you see in this photo, on the upper part of the photo near those fields, or those hills, that's where the water comes into the field. And then it runs down the field, and near the bottom of the photo is a creek. So you see when those rows get all the way through, I might let the water run a while longer so that it'll soak clear across the furrow. And some of the water will soak into the soil, and some will run right off of the field and right back into the creek. This is a rather simplified example. Sometimes it takes a longer route for the water to get back to the creek or the river. But in this particular case, I think some of those water molecules that are entering my piping system about a mile up the creek, I suspect that some of them only spend 4 or 5 hours out of the creek and before they get back into the creek. So the water that I'm running off my field isn't wasted. It's just taking a little detour as it heads on down the creek to the next person that can use it. So no, at least in irrigation systems like in western United States that are dominated by irrigation, surface water irrigation out of creeks and rivers, water that runs off the field, so-called wastewater, is not wasted. It is available for use by the next person downstream. So let's talk now about switching crops. Now there's something that actually can free up water for other crops or other uses, other people to use. If we switch to a crop, it consumes less water. And so why do I grow so much alfalfa and grass that use a lot of water, that consume a lot of water? Well, the answer reminds me of a story about an old-time bank robber in the Wild Wild West. There was a reporter that interviewed the robber, the bank robber, and the reporter said, "Sir, why are you always going around robbing banks?" And the robber said, "Because that's where the money is. And so I raise alfalfa and grass because that's where the money is. So I'm willing to switch to another crop if it makes economic sense. After all, I'm rather vulnerable if I'm raising crops that need a lot of water, that consume a lot of water." And in the last few years here on the farm, I've been experimenting with a crop called triticale. Some people call it triticale. And you see in this photo here that it's really a quite impressive crop. Now, this is not a edited photo. My brother and I are both over 6 feet tall, and you can see the amount of growth that the triticale puts on. And I like triticale because that stuff will grow for several weeks just on the hope that it's going to get a drink of water sometime. But nonetheless, I I think that I'm about done with triticale. I may use it in certain cases when I'm rotating out of grass or alfalfa for a year or two. But the thing about triticale is it's an annual plant. So I have to buy the seeds and plant it every year. And for that kind of production, like you saw in the photo, it takes quite a bit of soil fertility. Another thing is that triticale, when you cut it off and bale it, you're done for the year. It doesn't grow back. Whereas grass and alfalfa, it will grow back and you can get another cutting or maybe two um, during the season, during the summer. So all told, the alfalfa, a good field of alfalfa will probably outproduce a good field of triticale. Of course, when we talk about crop switching, the ultimate crop that doesn't use much water is bare dirt. So I guess I could save water by growing bare dirt. Suppose that gives a whole new meaning to the term "go eat dirt," huh? Okay, so let's summarize. Point number one: putting in an efficient irrigation system benefits the farmer who puts it in, but likely no one else except for maybe some water quality improvements downstream. Point number two: water leaving the field as wastewater is not wasted. Point number three: when it comes to switching crops, that the answer is simple: show me the money. Show me the money. If it makes sense, I'll do it. You know, what this all boils down to is that I can either spend money on technology to increase my irrigation efficiency, or I can spend water by letting it run off the end of my field or percolate too deep into the soil so that roots can't get it. I can spend money or I can spend water. And which one I choose to spend can vary from year to year and situation to situation. And that's why I'm bullish on this invention to attach drip tape to gated pipe. It gives me resiliency and flexibility. This year I don't have much water, so it's important for me to spend a little bit of money on drip tape instead of spending water. Next year might have lots of water, and it makes no economic sense for me to go out and buy a bunch of drip tape to irrigate my fields if I've got enough water to let some run off the end. Well, that's enough on the water for today. Let's go see what's happening on the long green line and how the water consumption has changed the plants since the last time you saw them. Okay, let's start at the beginning. Irrigated pipe, you see the adapters there. They're working fine, and they've got quite a few hours worth of working time and still doing well. So let's move on down the line. You may be able to see, you can't really see the end, but it's kind of down there by those trees. So the first section that we have here, I've reserved for some end of the season okra. It's hard to get too much okra, so it's about the 10th of July as I'm recording this, so it's probably about time to get that okra planted. And now we are coming upon the tomatoes. The tomatoes aren't doing all that well, but they're starting to come along. So we maybe have some small baby tomatoes here to see. We'll hope for the best. Then the next thing that we're going to see on the line is some Swiss chard. The grasshoppers are working on the Swiss chard a little bit, but it's not too bad. Hopefully we'll harvest some here pretty soon. And then we have some other plantings that didn't go very well. I had poor germination this year. Maybe I mentioned that already, and I'm not sure why. I didn't get very good germination either directly in the field or in some containers that I planted. Maybe it was too hot. Maybe I didn't water enough. Maybe I watered too much. It's hard to tell. So we're coming upon some row covers here. My cousin gave me some seeds, and these are a native bean that my grandmother's brother found in a area where there used to be some Indians, and he found the seeds. These days we wouldn't take the seeds, but it's been probably 50 or 75 years ago that he did it, and so at that time there was different sensibilities, and so I'm interested to plant those seeds. I hope I can keep the legacy going. They're a rather large red bean, look a little bit like an Anasazi bean, but quite a bit larger. So now here's quite a section of the long green line that I haven't planted. You see that the bindweed is doing just fine. I guess I'm a good bindweed farmer. You know, I sprayed this bindweed with a moderate dose of glyphosate, and I thought it was going to kill it, but it just made it sick. It's starting to recover, so uh, I'm probably going to have bindweed problems, but at least it slowed it down. It's not nearly grown as much as if I hadn't sprayed it. And you can maybe see there are some spots where the bindweed pretty well has died out, so I guess it was worth it. But I have made my peace actually with bindweed. It turns out it's fairly high in nutrition, fairly high in protein, and so I just let it grow in my hay fields and harvested it along with the alfalfa and the grass. And this is really hard to control. You'd have to spray a lot and plow, and I'm not into very much of either of those anymore. And I want to stop and show you a pea plant there. This is a forage pea. I planted some in this field several years ago, and they went to seed, and they're pretty good about regenerating themselves. Volunteer seeding, as we say. We wouldn't think of a pea as being a very drought resistant crop, but actually these peas do pretty well. They can grow quite a bit with quite a while without water, so I'm happy to see them. They will give some fertility to the soil with their being a legume, and so more power to them. Now we come upon the Three Sisters. We have here under this row cover a pumpkin. I've covered up the pumpkins with row covers to keep the squash bugs out until they start blooming and needing the pollination. And now we're on the corn. The corn, it's growing. The popcorn's doing okay. Sometimes it's suffering from grasshopper damage, as everything else on this long green line is suffering from. The grasshoppers are pretty well decimated the Aztec beans. There's one there, but the majority of the Aztec beans have been killed off by the grasshoppers' continuous eating of them. So that's life on the farm, I guess. Here are my biggest popcorn plants. Go guys, go! And so the Three Sisters are struggling because one of them is too tasty for the grasshoppers. I've also planted some more pumpkins here recently, but as I say, I'm not getting very good germination. There should be a pumpkin plant there, but there isn't. Here are a couple of young pumpkin sprouts there. By the way, we're at about the 500-foot mark on the long green line now, and moving on down towards the far end of the line. Quite a few of these pumpkins I planted did not germinate at all, and it's a puzzlement. I don't know why. So now we have another section here that I haven't planted yet. If I get a chance, I'll probably plant some more pumpkins. I don't know if they'll mature this late in the year, but I have space on the line, so I might as well give it a try. And then you see coming up here some more row cover. These are going to be pumpkins also, and they are doing a little better. I planted them earlier, and they're taking off pretty well. It's time to get them uncovered, but I'm trying to protect them as long as possible from the grasshoppers, and as long as they're not blooming yet, they don't really need to be uncovered. And you notice that the grasshoppers are not shy to eat through the row cover to get to the plants. I planted some Aztec beans here, but you can see how the grasshoppers have just decimated those Aztec beans, one after another, after another. I don't know. Some of them may pull through if they can survive until the grasshoppers have gone through their life cycle. They may produce later this fall, but I don't think I'm going to be able to raise beans as long as we have grasshopper infestation. So you see I have quite a number of pumpkins here. I'm hoping to have at least a good pumpkin harvest, if nothing much else. And then see, here are some pretty well decimated by grasshoppers, the row cover. And if you look closely, you may be able to see that they've reached in and started chewing on the pumpkins. So now after the pumpkins, I have some cucumbers. And the cucumbers sprouted quite well, but there's something wrong with them. Their leaves are all crumpled up and not growing very well. It would appear to be a disease or maybe a nutrient deficiency. I'm hoping that they'll grow out of it, but it's hard to know. They haven't done much yet. Although here are some that are starting to show a little bit of hope, but they should be much bigger by now. There's some still, even these, the leaves are not really what they should be. And now we come to some more pumpkins that are not covered. This is my best pumpkin plant on the line, and you see there's a bloom there. Also, the grasshoppers have been eating on the blooms. This is a male bloom. Pumpkins have male flowers and female flowers, and the female flowers are, the buds are still down there. You can see some that haven't opened up. So this male flower probably won't get fertilized since there's no, the female flower probably won't get fertilized because there's not any pollen yet available for it, but it's early in the growth cycle and it'll make it. Now here's some hoops that I'm doing an experiment with the research center nearby, the CSU Research Center. This is to try to avoid the squash bugs. This netting is from the organic fruit growers. It's a netting to keep away codling moths, and it's really quite fine. You can see the pumpkin under there. The hope is that this netting, there's a small native bee that the hope is can get through the netting to pollinate the pumpkins. If this works, this is going to be a showstopper. No, not a showstopper. It's going to be a great innovation, because those squash beetles, squash bugs can really decimate the squash plants. And now our final planting here, although it's not looking very good, but we have our much beloved okra plants here. The grasshoppers are even eating okra. Can you imagine? It just shows that they are not discriminatory, I guess, in what they eat. Here are a couple okra that look a little bit better. And so we come to the final sentinels, the final okra on the line, the sentinels of the end of the line. There's a final okra, and here, unfortunately, look at that. There's an okra that got chewed off by a grasshopper just the last day or two. And so we are here at the end of the line. You can see the end of the drip tapes, and I'll turn around and you can look back up to the top and maybe spot the beginning of the 1,000-foot line. Well, that's it for today. We'll see you next time on the long green line.